Okay, let's dive right into this explainer. If you've been paying any attention to the tech world lately, you know AI labs have spent years perfecting these massive large language models, or LLMs. But we are right in the middle of a massive shift. We're moving from models that just talk to systems that actually do, literally moving from simple chatbots to relentless action takers. So what exactly turns a language model into something that can research, book your flights, write code, or manage a whole project? Well, the answer is AI agents.
To really get why we need agents, we have to look at the limits of your standard LLM. These models are incredible at predicting text and explaining complex concepts. But if you ask a plain LLM a super simple question like, "What is the weather in San Francisco today?" you immediately hit a wall. Why? Because it doesn't have live data. It might confidently hallucinate a gorgeous sunny day for you based on old historical patterns, but it absolutely cannot give you the actual facts right now. I think this metaphor perfectly captures the core problem. Think of a standard LLM as a human brain floating in a jar. It's smart, it can reason, it holds a ton of knowledge, but kind of horrifyingly, it has no hands. It literally cannot interact with the outside world. It can't open a web browser, it can't verify its sources, and it definitely can't send an email. We humans are capable because our brains coordinate with our hands and external tools, right? An AI agent is exactly that. It's the brain, finally given hands, so it can actually interact with the real world.
So here is the absolutely crucial takeaway. An AI agent is not some brand new, ground-up language model. It's software. It's an orchestration layer built around the LLM. It essentially wraps the language model with specific components, tools, memory, and a reasoning loop, which allows the LLM to provide concrete value way beyond just guessing the next word in a sentence.
To give the AI this newfound agency, the software relies on three main pillars: tools to act, memory to remember, and a reasoning loop to actually get the job done. Let's break these down one by one.
Pillar 1, tools, equipping AI with hands. What's really fascinating here is how simple these hands can be. Tools are just external capabilities the LLM can access whenever it needs extra info or needs to take an action. They can be as basic as a Python calculator. So if you ask the agent, what is 17 times 24, the LLM realizes it probably shouldn't just guess the math. Instead, it outputs a structured call for the calculator tool. The agent software runs that math function, gets the result, 408, and feeds it precisely back to the model so it gives you a perfectly accurate answer. But the real magic happens when we scale this up to a multi-step request. Imagine telling your agent, book dinner for 2 tomorrow at 7 p.m. in San Francisco. This isn't a simple math equation anymore. This requires actual planning and execution out in the wild. Instead of just chatting back at you, the agent springs into action. First, the LLM requests a live web search for open restaurants. The agent goes out, grabs those search results, and feeds them back. Next, the LLM reviews the options, picks a winner, and hands it off to a booking API. Without you lifting a single finger, the agent navigated the web and completely secured your table. Moving on to pillar 2, memory, short and long-term context. If the LLM is the computer's processor, memory is the hard drive. An AI agent relies on two kinds of memory, so it doesn't totally forget what it's doing halfway through a task. Short-term memory is the LLM's context window. It tracks your immediate conversation, what the agent just tried to do, and its current plan. Long-term memory, though, stores information entirely outside the LLM. We're talking user preferences, past tasks, or entire company documents kept safely in external storage and only pulled in when the agent actually needs them. To put that into perspective, imagine you travel a lot. From previous chats, the agent stores the fact that you strongly prefer aisle seats and direct flights. Months later, you ask it to plan a brand new trip. It doesn't need to ask you about your seating preferences again. It seamlessly retrieves those specifics from long-term memory, pulls them right into the short-term context window, and plans your trip. It actually remembers you. And finally, pillar 3, the reasoning loop, the continuous motor. This loop is the real secret sauce. It's what transforms a one-shot chatbot into a relentless task doer. A super common pattern used here is called react. It's a prompting technique that forces the model into this continuous cycle: thought, action, observation. The LLM processes the context and has a thought. It decides on an action to run a tool. The agent then feeds the outcome back as an observation. And instead of just stopping there, the LLM reasons about that observation and iterates all over again. Let's actually watch this react loop in motion to see exactly how an agent systematically solves a complex request. Say you give your agent this prompt: Find a United flight to New York next Friday under $300.
Boom, the agent immediately enters its reasoning loop. Its first thought? Well, I need to know exactly what date next Friday is. It triggers a calendar tool and observes the result, October 18th. Armed with that exact date, the loop triggers again. Okay, now let's search for flights. It pings a flight API, passing in October 18th and your $300 limit. The observation comes back as a list of flights that perfectly match your criteria.
The observation returns the exact data it needed, and the LLM concludes its loop, successfully locking in United Flight 294 for a perfectly in-budget $280. It didn't just confidently guess, it reasoned its way to the goal step by step. And this highlights exactly why the reasoning loop makes agents so incredibly resilient. Because it's a continuous loop, if an API randomly goes down, the agent doesn't just crash. It sees that failure as an observation, and it tries again. Or if your request is kind of unclear, its next action isn't to hallucinate a wild guess, but to actually stop and ask you a clarifying question. It iterates and adapts until the job is legitimately done. We've seen how wrapping an LLM in tools, memory, and a reasoning loop gives it this incredible, world-changing agency. It's no longer just a system that talks. It's a system that actually gets things done. So I want to leave you with this final thought from our explainer today. If AI can now plan, act, and remember with this level of precision, what will you ask your AI agent